Good day, everyone. In this video, we will tackle about antiderivative of a function. Let's start with an activity. I want you to get your papers or scratch papers with you, or you can also solve it through digital solving or through digital whiteboard, and I want you to match the functions in column A with their corresponding derivatives in column B. You have it there, 1 to 8 functions in column A and A to H functions in column B. I'll be giving you a couple of minutes or just press the pause button of this video for you to have more time in solving the derivatives from column A to column B. Now let's discuss your answers. Let's proceed to the next page. In the previous discussion, we learned how to find the derivatives of different functions. Now, we will introduce the inverse of differentiation. If you are wondering if is there an inverse of differentiation? Yes, there is. The process is called anti-differentiation. This process is called the inverse of differentiation. Let's proceed. There is a natural question that would exist. Given a function f, can we find a function capital F whose derivative is f? We might be wondering if we could answer this question. And let's try to discover the answer of this question at the end of our video. By definition, a function f is an antiderivative of the function small letter f on an interval I if f prime of x is equal to f of x for every value of x in I. Okay, so this is a general definition, and please take note for this definition, for this will be very useful as we move on to the solving part. Again, you need to take note that a function capital F is an antiderivative of the function small letter f on an interval I if the f prime of x is equal to f of x for every value of x in I. Take note that in our first activity here in the matching type, you were able to solve the derivatives from column A to column B. And these column A are all the functions here in column A are the anti-derivatives of column B. Again, the functions here in column A are the antiderivatives of column B. That is the other way around. When we say that column B are the functions here in column B are derivatives of column A, therefore in column A, they are called the antiderivatives of the derivatives there in column B. And that's how we answer this matching type from the previous activity or previously. Let's try to discuss further with the examples. Let's have example letter A. An antiderivative of f of x is equal to 12x squared plus 2x is the capital letter f of x is equal to 4x cubed plus x squared. Try to double check. It's all because why is it like that? If you might be wondering, if the antiderivative of this function is this function, that is, as we can see, the derivative of f is given by f prime of x. So we solve for the derivative of this function. And as we solve the derivative of this function, we are going to arrive with an answer 12x squared plus 2x, which is equal to our f of x. That's why this function is the antiderivative of f of x, which is equal to 12x squared plus 2x. Let's have another one. An antiderivative of g of x, it's only one of here again. An antiderivative of g of x is equal to cosine x is the capital letter G. G of x is equal to sine x. Okay? If you know the reason why, it's all because just the same. G prime of x is equal to cos x, and that is equal to our g of x. And that is the reason it is called the antiderivative. Let me eradicate the off there. Okay? There you go. Let's continue. And for remark number one, I want you to take note this remark that the antiderivative capital letter F of a function f is not unique. Why did I say it is not unique? For there are also other antiderivatives of a given function. Let's try to discover that in our next activity. Other derivatives of f of x, which is equal to 12x squared plus 2x, are the following. Remember, we're using the same function, 12x squared plus 2x. We have f of 1, which is equal to 4x cubed plus x squared minus 1. Okay, so these are other antiderivatives of f of x, which is equal to 12x squared plus 2x. Same goes with f of 2. f, f of 2 of x is equal to 4x cubed plus x squared plus 1 is also an antiderivative of the function 12x squared plus 2x. Okay, so I forgot to write there. It's antiderivative. Okay, there you go. So that's an antiderivative. I'm so sorry for the word. So that's antiderivative. This function and this function. That's the reason why we cannot say that it is unique, for there are other functions that would serve as an antiderivative of a given f of x. For example, as you can see it here. We have it there, this one, and this one. And therefore, there exists, or in fact, any function of the form f of x, so the capital letter f of x, which is equal to 4x cubed plus x squared plus c, okay, where c is an element of a real number, is an antiderivative of f of x, which means we have it there any value of c. Okay? Observe that f prime of x, which is equal to 12x squared plus 2x plus 0. Remember, you have it there 0 if we are going to solve one of our f here, capital letter F. That's plus 0, for this is constant. It is just equal to 12x squared plus 2x because automatic 0 is just equal to this. And that is equal to our f of x function, which is the small letter f. And that is how we discover that an antiderivative of a given function is not unique. For there exists a theorem that if capital letter F is an antiderivative of small letter f on an interval I, then every antiderivative of f on I is given by f of x plus c, where f is capital letter, where c is an arbitrary constant. When you say arbitrary constant, these are any constant that we get from value or from any group. It can be on a real number. In this case, we get this arbitrary constant from the real number. Arbitrary or can be random constant numbers. It's not necessarily negative one, positive one, but arbitrary from the word itself, arbitrary. And there is a remark number two, and you need to take note for this. Using the theorem above, we can conclude that if f sub 1 and f sub 2 are antiderivatives of the function f, which is small letter f, then f of 2 of x is equal to f1 of x plus c. That is, f of 1 or f sub 1 and f sub 2 differ only by a constant, right? So let's go back to our page. As you can see it here, they are just solving their f prime of f sub 1 and f sub 2, we will get the same answer, which is 12x squared plus 2x. And that explains remark number 2. Now, it's your, before we proceed for our exercises, we have some terminologies and notations to take into account. The word antidifferentiation is the process of finding the antiderivative. The symbol integration, or this one, also called as the integral sign, denotes the operation of antidifferentiation. The function f is called the integrand. If f is an antiderivative, again, if capital letter F is an antiderivative of small letter f, we write the integral or the integration of f of x dx is equal to f capital letter F of x plus c. The symbols uh, integral sign and dx go hand in hand, and dx helps us identify the variable of integration, which means dx means that it should be integrated in terms of x. Okay, that's the purpose that's the purpose why it helps us identify the variable of integration. The expression f of x plus c is called the general antiderivative of small letter f. Meanwhile, each antiderivative of f is called a particular antiderivative of f. If we get each, no? If we are considering each antiderivative. But generally, the expression f of x plus c is called the general antiderivative of x. Okay, so there you go, the terminologies and notations. For exercises, we have it here 1, A, B, C, and D. I'll be giving you an ample of time to answer this one. Determine the general antiderivatives of the following functions. Okay? So we're just solving for the general antiderivatives for A, B, C, and D. And pause for a moment. If you're watching it on YouTube, please pause for a moment and answer 1, A, B, C, and D. I'll be just maybe for about 4 to 5 minutes. Now let's proceed to the next activity or next exercise. Matching type, okay? Match the functions in column A with their corresponding antiderivatives in column B. You have it here, functions A to F. And then in column B, we also have a capital letter F as our function, A to F also. Please take your time in solving. You can double check your answers. I cannot give you an answer key here in my video, but you can use some integration calculators or using any application for calculation such as Photomat and other application that can solve an integration or applying also derivative reversely. Thank you so much, guys. And that ends our discussion for this video. Have a good day.